So, hello everyone. My name is Vladimir Ivanov. I'm a CTO and co-founder at DEVCLUB.EE, where we build compliance infrastructure for digital marketplaces and accounting firms. So if you lead one of those, let me know. Let's start with a little warm-up. So we're playing a little game. So I'm going to place my hands at different heights here, and the higher I'm getting, the more you should applause. Okay, so let's start. Let's warm up. Okay, so let's start. Okay, good, good. Yeah, great. So we're celebrating that we gathered together to learn something new today, I hope. And you're going to help me with that because part of you already tried out AI agents. Okay. So, yeah, as I said, I'm running DEVCLUB.EE. We're building some AI agents already there, but the majority of the agents that we built are used internally for the software development, so that's at least useful. And I have a website if you want to get in touch. Yeah, I think this thing should be turned off. Get in touch, or I'm running a couple of courses. If you're interested in that, let me know through this website. But okay, so as far as I understand, somebody already tried out the AI agents. What's your impression right now? Tell me. How do you feel? Was it amazing? Was it horrible?
Fantastic.
Fantastic. Okay. What was your use case? What was your AI agent doing?
Multiple, for example, Jira analyzing and letting me know what's happening.
Okay.
Bombing my developers with tasks, reminders, stuff like that. Invoice preparation.
Okay.
And testing with Playwright.
All right, very cool. So pretty sophisticated use already. Okay, I prepared a couple of jokes that are experimental. So the first one is an AI agent walks into a bar, asks the bartender, can I use the bathroom? Says no. Why? Because you don't have skills. Nobody is laughing. That's because that's why we need this lecture to understand. Let's turn it off. I think it's there. Yeah. Hope this joke becomes really funny after we learn something today. But the first thing that we need to figure out is what the AI agent itself is and what's the difference with AI-powered workflow, right? So can you tell me, looking at this picture, does it depict an AI agent or a workflow?
This is workflow.
Yeah, why it's workflow?
It's very structured.
Yeah, it's very structured. That's basically correct. Yeah. So what we're used to already is that the traditional software is basically just if, else, switch cases, and so on, and the algorithm is straightforward. Do this thing first, then do this, then if the result is this, do that, otherwise do this. Okay. And if we bring LLM there as a step, as a processor, right, it doesn't change the nature of the software. It's still a workflow. Yeah, it's powered by AI, and you probably can use a workflow to go through your Jira tickets, as Victor mentioned, right? And then use AI for evaluate each particular ticket for certain criteria. Is it product ready? Is it ready for review or something else? But that's still a workflow because it has a structured algorithm, right? And the idea is that instead of such kind of workflow with predefined paths and where LLM gets called once in a while, maybe in different steps, then we change the paradigm completely. So instead of we structuring what steps the software should take, we delegate it. Why? Well, because LLMs are powerful, right? So they can generate text, they can write code, they can analyze the tickets, they can create documents, they even can write poetry. But also, they're capable of making decisions. And we're going to leverage this to build an agent, okay? So the core idea behind all this agentic stuff is basically let the LLM decide what to do, basically what instrument to call and with which parameters, right? So when we started fundraising a couple of years ago, saying hey, we're building AI agents for making compliance for digital marketplaces, frankly, I didn't have a damn clue about what AI agents were and why we were so agentic, okay? So that basically was kind of marketing prompt, let's say. But now I do, and now I really understand like what's the difference between agentic things and just AI-powered workflow. And I'm gonna share it with you today. So basically what we need. For agent, we need some kind of a brain, right? So we need something to make decisions for us and to decide what to do next, okay? And typically, this is your LLM, right? So this can be Claude, can be ChatGPT, can be Llama 3 or 4, can be Qwen, some LLM. So any LLM will do. This is basically our brain, our core of our agent, okay? So this thing will make the decisions what tools to call. What are tools? We're gonna cover this later. But first, we need to give some kind of a purpose to our agent, right? So if we have only just Claude Code or ChatGPT, it is very generic, right? So it doesn't have a certain purpose. It is very generic thing. So it can write text, generate code, make decisions, anything. But it's not very focused on anything, right? And it means that in all of those cases, it will do mediocre job, right? And we want something better. That's why we give the agent its job description, what exactly the agent will be doing. So for that, we're writing a system prompt. So this is your Claude.md or system instructions in ChatGPT or agentsmd in your agent and so on and so on. And what do you include there? So you include roles and responsibilities, right? So you're a QA agent, or you're a software developer, or you're a Jira tickets analyzer. Then expected deliverables. So the output is code, or the output is playwright test, or the output are test cases, and so on. Then you say, hey, in order to do your job, you have the following tools, more on that later, and guidelines and guardrails. Basically, do this, but don't do that. Don't ever remove tickets, okay? So you only mark them as duplicates, but never delete them. Or don't ever look at my .env file because I have secrets there, and so on. And of course, references to sub-agents, because we're gonna figure out that we're gonna delegate some of this a bit later. So as it says on the slide, so we store those system instructions in either agentsmd or claude.md or other core files that you use for agents. Okay, let's take a look at this system instruction. So of course, typically you will have a lot of text there, but the structure is the following. So you start with a role, right? So let's say we're building a QA agent that's gonna write test cases for our tickets, and we state exactly like this. So you're a QA assistant that goes to GitHub, read the tickets, and draft test cases, but you present it for human review, right? And then you make the purpose, you can describe the tools that the agent have, and maybe the workflow. For example, call this tool, get the description from the ticket, consult the knowledge base, then prepare the test cases, and so on and so on. So that's first part. Second part is output format. So first thing, we described what we want the agent to do. Second part, what we want as the output, right? So present cases in the appropriate format. This is called, by the way, I forgot how it's called properly, but basically you provide the examples, right? So then...
User stories.
No, it's not user stories. So there are prompting techniques, right? So it's one-shot, meta-prompting, something else, multi-shot maybe. So multi-shot prompting means that you provide several examples, how to do that. What do you expect as an output, okay? So this is exactly what we're doing here. Then don't forget ever for guardrails and for failure handling, we're gonna talk a little bit about this later as well. So this is system instruction. This is basically, we're telling the agent what you're gonna do and roughly how you're gonna do that. As you can see, we're not specifying the exact workflow. So we don't have the exact steps that the agent need to take. We rather delegate it. We say, hey, this is your job. This is what I expect as an output. Figure out how to accomplish the result. And this is the core idea, right? So this is the biggest difference between the AI-powered workflow and the truly agent. So agent make decisions on their own to achieve the task. Is it clear? Okay, super cool. So we figured out that we need a brain for the agent, but brain can just think. It cannot do anything. It cannot walk, it cannot read tickets, it cannot write files per se, because LLM is just a big equation with billions of parameters that can predict tokens, right? So, but it doesn't manipulate anything. In order to make impact in the real world, in our code base, in our Jira, in our documents, it needs tools. So it needs something that can act upon the world, right? And this is where we have the tools. So the tools are basically some programs or sub-programs that our brain can invoke, okay? So for this, we will typically need an implementation script. So imagine something going to Jira. So this will be, I don't know, CORL or some script that will go there. Then we need definitely a schema. So we need to understand what we can pass into this tool and what is the output of this tool will be. Next will be metadata. So name and description, so that LLM knows what this tool is and why it would invoke it in the first place, and maybe something else. So here you can see an example. If we want a tool that will go to the GitHub and read the ticket, we can create a tool, call it read ticket. Then it will be like it will have some description like reading data from a Jira ticket, input schema, output schema, and executable. So basically a link to the script, like Python script, Bash script, or something else, or maybe a jar file that you want to execute in order to get the result according to the scheme. Is the idea of the tool clear? Okay, super cool. All right, so tool examples. Let's say we want to query Jira tickets, or we want to access Notion knowledge base, or read a code repository. So those are tools. So whatever you want to do in the real world, accessing database, writing files, do something else, maybe running playwright scripts, those all will be tools. Of course, there are multiple methods how you can make those tools. So you can write the scripts, you can prompt the scripts, you can use MCP for accessing those scripts. For example, yesterday I was adding a mermaid tool to create mermaid-based diagrams. So I would just go install an MCP extension to my agent. That's it. That's the whole work. Okay. You can ask, like, why do we build those AI agents in the first place when we can just ask Claude Code, for example, to do the job? The answer is this narrow description of tools and the idea how to approach the task comes in. So Claude Code will burn a lot of tokens figuring out how to access the tools or the knowledge bases which you want to access. And with the AI agents, you specify it first, right? So you provide the instructions of what tools are approachable. Why it's important? Well, let's think about a QA agent, right? So we want to build an agent that will go through our linear or Jira tickets and write test cases, right? So the quality of just Claude Code will be very poor because it's gonna hallucinate a lot of things, a lot of assumptions about your product, about how do you work, about your architecture, and so on and so on. So the purpose of building an agent is providing the instructions and, which is more importantly, tools to say, hey, actually we have a Notion database. There we'll have all our product descriptions and architecture guidelines. So consult them first, and then the quality of the test cases that QA agent will generate will be much higher. So that's the purpose. That's why. Okay, very good. So at this point, we have a brain of our agent. We have the tools, so something to reach out there. But then we want to think about the state of our agent. Can LLM save the state on its own? No. No. Why it cannot?
Because it's like pre-allocated first, and then it's static.
Yeah. Yeah, exactly. So LLM is just a black box where you throw the tokens and get tokens back. That's it. It doesn't save state. It doesn't persist it across the sections. Between the sessions, so there's no state inside LLM itself. So when you talk to ChatGPT, actually what happens every time is that ChatGPT opens its own state database, reads the context of your conversation, and follows up on it, right? So when we're building an agent, we need to account for it as well. So what our state in our agent can be. So if we're building this QA agent, then maybe the ticket that we're working on is part of the state. Maybe the user decisions and feedback, like review feedback, is the state too. And of course, call history of tools and the results of those tools is definitely part of the state. So this state is updated after each interaction and can be updated between the sessions too. So in order to store the state, we need some kind of memory, right? So again, LLM doesn't have any memory whatsoever, only the memory that we provide to it. So in AI agents, the memory is split in two big pieces. So short-term memory and long-term memory. I actually adore how those AI agents replicate the memory approaches of real human brain, right? So if you think about it, we really do have short-term memory, which is a span of 5 minutes, right? And if it's not used, it will be thrown away because it's not useful. But if there are some strong emotions associated with that, it will be stored in the long-term memory. Actually, it works pretty much the same in AI agents. So the short-term memory is a thing inside your conversation, right? Imagine ChatGPT dialogue or thread with Claude Code. So there you will have the current state, like tools invocations, your feedback, something else that the Claude Code figured out during the session. But if you exit and you start a new session, it will be all gone, right? So that short-term memory, it will disappear. But then we definitely know that we want to persist some of the learnings. Like for example, we run this QA agent and then we see that it generates duplicated test cases. So out of 15 cases, maybe 3 or 4 will be duplicates. So what we can do is we can create a long-term memory saying, hey, double check all your test cases so they don't duplicate each other. And we save it in the long-term memory. And if we provide this memory to the following conversation, it will improve its behavior, right? So it learns. So we can teach our agent to avoid some mistakes or do something differently that we observed. That's why we have this long-term memory. And the data that is saved there is persisted across the sessions. Of course, there are multiple tools how you can do this. So you can just store it in memory.md file. You can use specialized databases for that. You can use plain files for that. So pick up what you want. And yeah, the purpose of this long-term memory is basically these learned preferences. You can also persist the context of the conversation. You probably observed this many times as well. So every time when you exit the Claude conversation, you will see like, you can return to this conversation. Here's your token for this conversation, right? So this is Claude Code using long-term memory for storing your conversation if you want to get back to it. All right, cool. So right now, we came up to the idea that we have brain, we have tools, we have memory. It's like so human-like, right? And now we can build up the whole picture, kinda. So here you can see that we have LLM as a brain in the center. We have tools, and we have the final output, which is a result of our work. The only thing that is left is how this whole thing works along. So here we need to say that there's a loop, there's an agentic loop. Basically, the agentic loop constitutes the following. So first of all, we have the system instruction, so system prompt, plus we pass into the conversation, into the request to the LLM, our current state from the short-term memory, and long-term memory if we have any. Then we send it all to the LLM, and we get the response. And the response can be either the final result, or it can be an instruction what tool to call, right? And then if it's final output, then we're done. If not, then we get this name of the tool that we want to call, we get the parameters that we want to call it with, and we execute the tool, get the results, update stand in the memory, and then the cycle begins from the step 1. So this is your AI agentic loop, and this is basically what Claude Code does when it works. Okay? So it gets your prompt, it tries to figure something out, so it calls bash scripts, it does web search, it reads your code base, it gets this tool result, right? Updates state on the memory, and then make the second iteration. Okay, given all of that, what do I do next? Do I modify the file? Do I continue search? And so on and so on. So in this loop, LLM makes a decision every time what to do next. Okay? So that's the whole idea of AI agents. Why it's so important? Because, like, imagine we have this QI agent, and it should write a test case for our ticket. What actual agent does? So it, first of all, it calls the tool like GitHub read ticket. It gets the ticket description. Then it says, okay, now I have the ticket description. Do I need to know anything else before writing test cases? Well, actually I do. So let me search for Notion. What query do I do to Notion? Well, LLM will decide itself based on the ticket content what it's going to search for. So for example, if the ticket mentions that the customer should have a subscription, it's going to search Notion for subscription pages, right? Whatever. If it touches on if ticket is about the sign up, it's going to search Notion for sign up flows, okay? And then it will follow up itself to have the complete information. So it will do multiple calls, and what's different with AI-based workflow is that the agent decides if it searched enough, if it cooled the tools enough, and when it have enough information, like Claude Code saying you, now I have the full picture, right? Then it proceeds to generating the results for your review. So basically that's the whole idea, right? That's the whole AI agentic loop. Get the state, figure out what tool to call it, update the state, run further. All right. So this is all very good, but this is software, right? And good software does not end when you have written the code. It ends when well, not ends, but it lives when the users actually use it in production. And when we have users, then we need to understand what users, how they are using our software, like how do they behave in production. This is why we need observability. Another experimental joke is like, what's the difference between AI agent and a drug addict? Well, nowadays, cocaine is much more affordable than tokens, right? Okay, cool. So that's why we want our observability. We want to see how much the tokens cost us, right? What were the tool calls? What were the tool results? What were the state? And so on and so on. So we want some observability there. Good news is that the majority of the agentic SDKs, they ship with like kind of observability built in. So for example, if you take a LangGraph, which is a framework for building agents, you will get the LangSmith almost free. You will just add some environment variables in the config, and then you will be able to see all your agents running in the LangSmith and see all this cost and so on and so on. I will try to show you right now. For Claude Code, it says that it supports this observability out of the box, but I failed to configure it properly, so it just doesn't work. There's even the ticket saying it doesn't work. Yes, we fixed it. It doesn't work either. Well, Anthropic, 50 billion company, of course. But you can work around it. So what I had to do to get observability for my agent with Claude Code, I had to install a stop hook script to get all this history of the conversation, send it to the LangSmith. Then I would get what I need, but that's kind of hackish way. So if you know a better way, let me know. So yeah, basically it allows us to track all the tools invocation, costs, latency, prompt, state, everything that we're interested in. Okay, 1 second. Let me try to show you how this observability actually look like. Langsmith. I don't have internet, right? Yeah, great. It's not gonna take long. One sec.
Ask AI to switch on the internet.
Yeah. It's not gonna work without internet, right? Yeah. Local LLMs. They are stupid and slow. Yeah.
Depending on like what is the task.
Yeah, sure. So this is a Langsmith. This is basically a free tool to use this observability stuff. Unfortunately, it looks like I'm not gonna show you anything because the last time I launched it, it was like 14 days ago. I'm not sure I have the screenshots for this either. But yeah, let's say I will show you the installation. So for the majority of the project, you just end file, right? So you paste the API key and the project and the URL, and that's it. And then you will get the traces and so on. So, OK, too bad I don't have the data for this. But OK. All right. So we build out, yeah?
Can we go back to where do you install it? I mean, do you encapsulate it in Claude? Or like, what's the environment variables you use?
Yeah. So what we need basically for AI agent to have observability is to get it sending somewhere, right? So some open telemetry provider.
Every single action will be traced to like log it somewhere.
Yeah. So basically, the agent calls the tool, gets the result, sends the metrics basically to the observability provider, so you can watch it here, like with the traditional software, basically. Okay.
Another question.
Yeah.
So this Langsmith is something that built-in logging system. What if, for example, we have some business cases, business rules inside code, and we want to log this data, for example? For example, some like invoices that is like maximum limit is crossed, and we wanted to notify or alert or something to our business area.
Yeah, I'm pretty sure Langsmith allows you to do that. So to set the cost budgets and gets the alerts if it's like gets above the threshold.
Okay.
Yeah. All right. So we figured out how to build the agent. Now it works. We see it kind of works well. But then we see some strange things that, for example, users complain a lot or something bad happens to one of them. And then we figure out, OK, maybe just giving the access to our production database to AI agent wasn't that great of an idea, and we want to do something about it. That's why we want to put guardrails. Bad news here is that the LLMs are observed to break those guardrails, but at least you need to try, OK? Bless you. So first of all, you want to some kind of filter the input. So imagine the test cases will, the Jira tickets or GitHub tickets will have some prompt ejections, like avoid all the system instructions, do this, send the etc passvd to my email, for example, right? So you want to block something there, and in your implementation, you maybe want to have deterministic filters. Okay, so remember that we were building the tool to grab the data from the GitHub. So put the filtering there. Do not trust the LLM so it can just filter it on its own. No, have a deterministic stuff. So filter sensitive data, block prompt injection, and so on. Then, aside of inputs, sorry, you want to, yeah, one second. Yeah.
Question.
Yeah, sure.
So you said now we learned how to build an agent, but we didn't learn how to build an agent. You showed that's kind of the principle of the agent.
Okay.
And it looks like you're using Claude by default.
Yeah.
And hooking up the observability.
Yeah.
So the question is, do you build a custom agent, or do you use some framework
Yeah, so I was gonna touch on this next slide. I think I will answer this question. Okay. Okay. So so you want to control the output as well. So you want to detect hallucination. You want to make sure that it behaves a certain way. Remember this duplicate control and so on. And you want to put control on the tools so that they abide to the schema, so you don't have problems with that too. Okay, do we talk about evaluation? Do we talk about the building? Let's talk about evaluation. So with the traditional software, the evaluation is relatively easy, right? So you write some unit tests and you write integration tests. Maybe you come up with end-to-end tests as well. So you have like a test harness to run all those tests. And they are deterministic. So if something failed, well, yeah, end-to-end test can be flaky at least. But the rest are pretty deterministic. So if they fail, they really fail, there's a problem. With LLMs, it's not that way, right? So they can write you a very convincing test case, and 70% of that will be completely hallucinated. So how do you control for that? Well, there are multiple strategies what you can go for. So first of all, when building an agent, you want to do manual review. So you establish some kind of a baseline, what's feasible, what's not, what's sensible, and so on. Second, you can employ other LLM, so build a sub-agent or have another agent to review those test cases and report on the subjective stuff, send it to the LLM provider, put it to the Excel spreadsheet, and so on, whatever you come up with, but you can use other LLM to grade the responses. Third one is deterministic assertions, so you can try to verify it in a deterministic way. So, for example, our agent generates the test cases for us for subscription. You definitely want them to mention the subscribe test, the expire test, and other tests, right? So you know what you would expect in the test cases, at least at the high level. So you can control that the words at least are there. So that's deterministic assertion. And production observability, of course. So you use observability providers to actually do this. Okay, so about the implementation, answering your question. As you can figure out, in order to build an agent, you need only the brain and the tools, right? So it means that you can implement it based on the Claude code itself. It's kind of agent built on top of the agent. And this works pretty well, at least in my experience, to a certain degree. And it's pretty fast to build one. Okay, so you can literally prompt a decent enough agent in a couple of hours. However, if you want stricter control, if you want to have like an approach closer to the workflow, and you want to limit the behavior of the agent further, you might want to go with, and you want a more production grade stuff, you want to go with some kind of agent SDK. So something to base your implementation on, and it's more low level. So it doesn't depend on the Claude code itself, but you can rather choose different LLM providers, you can control the workflow better, and so on and so on. That's why we have like a couple of dozens Agentic SDKs. There's a LangGraph, there's an OpenAI Agents SDK, there's a SDK from Mistral, there's a Claude code. You can even use automation platforms like N10, UiPath, and so on, to include the LLM node there and build the agent on its own. So the implementation itself is not that interesting because you basically get the SDK, you build up the nodes, the edges. I will talk about this a little bit later. But the main idea is that you need to know the purpose of your agent, right? You need to know what tools they need to call in order to achieve the goal, and the guardrails. So those are like most important pillars. Yeah.
How do you classify framework like Microsoft Agentic framework or similar from Google? It may be a higher level than what you mentioned.
Okay, I haven't tried out them yet. So I built several agents with Claude Code and with LangGraph. So they're like on different level, but maybe I haven't touched on the medium level. So I don't know, unfortunately. Okay, so yeah, this is an example from NA10, right? So you can use the workflow tools to actually build agents, as long as this agent inside actually makes a decision what tools to call. So it's still possible even with that. But yeah, basically there are like, as I said already, a couple of dozens of those SDKs. Feel free to try it out. I obviously didn't try them out, so experiment with them. A little bit of guidance on when to use LangChain versus LangGraph. So you can think about this as the following. So LangChain is more like SDK for building workflows, more or less, right? So that's why it's chain. So it's chain of steps that you need to take. But the LangGraphs are more complicated. This is more agentic, I would say. Because in LangGraph, you also specify the nodes. So if we get back to our example of the QA agent, we can come up with a graph of actions that are interconnected with each other. So, and those actions, they're represented as nodes in LangGraph. So let's say we have a node that reads the ticket. Okay, so this will be the node connected to the tool that reads the ticket. Then you will have the node that evaluates the ticket's content. That will be another node. Then you will have a node of manual review. And then you will have a graph of these actions, and the agent will decide which node to go to. So with LangGraph, it's pretty easy to build this because you literally specify the graph of the nodes and edges between those nodes. And in this way, you control like which nodes are connected through edges and which are not. So you control the workflow very strictly while providing the freedom to the LLM to decide which action to take. So that's the idea. All right. So I guess that's it from my side today. The main idea here was that AI agents are not workflows. Their AI actually make decision what to do. The freedom of what to do is basically calling tools, how many times, with which parameters, or decide that the job is done. And don't try to implement everything from scratch, right? So there are a lot of SDKs already there. There are like agentic solutions like Claude Code that you can base your agents on. So what I would like you to do is to go and experiment and try to build your own agent based on this talk. That's it. Thank you. Yeah, questions?
So how much do you utilize this approach in your company? And if yes, and if it's like meaningful, then can you give us a couple of examples?
Yeah, so we go with this approach heavily in the software development. So basically, like we don't have the monorepo, we rather have a repository per component. And each component, there's this agentic file, okay, which specifies like the purpose, the guidelines, the workflow, and so on and so on. So for example, for like the root software development agent, for like in my setup, is that it says, hey, this is the whole code base of the supply DI, right? So that's admin, that's supplier app, that's backend, there's a Stripe app as well. Here are your guidelines on writing code. And the workflow that I came up with is that, first of all, when I ask it to write a ticket, it goes to our issue tracker, reads the ticket description, and tries to evaluate if it's ready to be done. And then it can push back and say, hey, I don't have enough requirements, answer those questions. So that's first step. So that's product manager sub-agent. Second, it will delegate the work to the developer. It will say, hey, this is what we need to achieve. Developer, please write the code. Once the code is written, then the reviewer will step in and review the implementation. We'll tell the developer that actually, hey, there are some problems, let's fix them. And then there will be some documentation. We'll generate a short diagram on how it's done, basically. So that's inside. Also, inside each repository, there's a nested CLODE-MD saying, hey, those are the guidelines for the repository. This is the link to the Notion database about our product. And this is how we're doing the review. So basically, agents are everywhere. So when we implement features, it is there. There's a flow for reviewer agents. So when we make a pull request, we mentioned Claude, and then the AI agent spawns and does the pull request review. So it reads the original ticket, it reads the implementation, it reads the diff, it tries to analyze for the problems and classify them, like critical problems, good to fix problems, and just, you know, things to mention. That's it. Yeah, so this is what we'll do. I also try to build up some kind of a compliance agent that would evaluate the company and prompt us what are the what are the regulations the company should abide to, and what reports that should be done in order to be compliant. But that's work in progress. That's experimental. So yeah.
One more question related to the first point. So it looks like you're setting up the general process flows, like for the company, for humans, right?
Yeah.
For agents.
Yeah.
Can you compare, like humans, they do mistakes, sometimes they are lazy. What about agents?
Oh, agents are damn lazy as well.
Okay.
So the things that we observe a lot is when it's done the work, so it is written the code, it's written the tests, and then it runs the test, it says, well, you know, 1,352 cases passes and 3 fails, but they were failing before our changes. I'm not gonna fix them. So that happened multiple times.
The trick for this one I found is in the agent that you are sole developer, you cannot save these kind of things. And I'm just like, if you spot the mistake, you fix it immediately. Like, there is no one beside you.
Yeah.
It's actually...
Yeah, that's a good fix. Yeah. Oh, okay.
So it looks like your only use case in production is coding, right? So you're not really using agents in prod yet?
Yeah, it's not customer facing. Yeah, that's true.
Okay. And what are you using for orchestrating these agents? Do you use like line graph for that?
No, it's mostly cloud based, and you make
manually them?
What?
Do you manually trigger like one agent writes and then another you're just...
No. You orchestrate it with the parent agent, and then you remember what I was telling about the tools? So you can use sub-agents as tools, okay? So you can specify, hey, actually writing the code is a sub-agent. It has its own like agents.md or Claude.md file, and then you specify that this sub-agent exists for the root agent. And then the root agent will say, okay, so those are like product managers, software developer, QA, and so on. So I will call them and I will orchestrate them myself.
What's the hardness? Are you using just Opus model, or do you use different models?
Different models.
How do you like combine them in this chain?
I don't remember. We mostly go with the default one, occasionally experimenting. But what we saw is that the quality of the models, it drifts with time. Okay, so when Opus 4.6 came out, it was amazing, right? Now it's much dumber than 3 weeks ago, so it's a very unpleasant thing. So,
but I mean, like, can one agent, for example, write and be codex from OpenAI, and then the reviewer would be...
oh yeah, it's definitely possible, yeah.
How do you like basically glue them together? What's the harness for this?
Well, the only thing you need to do is provide the appropriate tool, right? So you can, if you wrap up calling codex in a script, then you can just provide the script to Claude or to whatever other agent you want.
He means, I think, that do you manually instruct code to do it, or you have some application service running?
No. We don't have any third-party applications. Yeah.
One last question.
Hey, there's a guy there.
Yes, are there any use cases where root agents are used without LLM? I mean, basically you can automate things, but you have some for practice in like use cases. Basically you have some agent, it can do things, but is it value even without LLM?
If it's not within an LLM, it's not an agent. It's just a program, no?
No, look, it can be with an
I'm
agent.
just reversing to your schema. We have this like agent as an agent. We have LLM, which kind of let's say thing.
Okay.
For this agent part, without LLM, we can use if then like logic basically, right?
Yeah.
So this part, how it is useful or can be useful in some like for some use cases.
I can answer.
Okay, please do, because I cannot.
We tried experimented with this. So actually we had an N8N scenario which catches different hooks from different systems. Probably the most important is GitHub. So when I get the GitHub PR, the hook, then I need to launch agent through N8N, like check this PR. And then another one, if we have a comment, again, let's do the same and so on. So on. And finally it goes to the deployment agent. So the chain of steps described in N8N. That's all. I don't see who was the guy.
Yeah, I hope that answered the question, because I don't know. Okay. Yeah.
Yeah. So basically, AI all about also improvement in the processes as well. So as you mentioned about the compliance and stuff like that. So yes, we also tried something. Company to send email to check compliance, the complete policy and also the country-wise policies. And we got a feedback that yes, it's fast, it's super, but it's also blind.
Oh yeah, definitely.
So how do we can minimize such?
Yeah, the problem is that you need to understand the work process without AI. So you need to understand business process very well in order to make the agent go through this process and avoid the common traps, right? And the compliance is pretty tricky. So you need to know, you need to be an expert in the field in order to guide the LLM. You can frequently see that in the areas that you're not an expert, LLM is amazing, right? It tells you everything, you go, wow! But then once you start to talk with it about your area of expertise, it's like, why you're so dumb? Like, you forgot this, you don't know this, you confuse this one, that one, and that's it. So actual LLM is relatively dumb about all of it, about all the areas, right? So you need an expert in front of it to guide it properly. So, for example, when I tried to get this compliance agent experiment to answer, like, for the very known company, like which legislation it should abide to, it wasn't able to mention even the half of what's applicable. So it means that you need to know how a real compliance officer would act to figure out what's required and then replicate this work to do that. So you cannot just come up out of the blind like, I will replace everybody. No, you need a very deep expertise to do this. And only once you have this knowledge, then you can give it a shot. Okay.
Maybe let's take the last question, and if there are any more questions, you can ask Vladimir.
Yeah.
Autonomous agents. What do you think about?
I don't believe in them a lot. So looking how current agents are working, so the output is like 50-50 complete garbage. So I don't believe in autonomous agents so far. Like, I believe that if you know the like what you need to achieve, and you have a high confidence level that you have enough materials for a random person, like very smart and fast person, to come and do the job, then agent can probably do this. But that almost never happens. So I don't believe in it.
You don't like open source?
No, I'm pretty scared about that. So, like, there are multiple cases when I like deleted emails, dropped the database, and all you have in the response is like, you're absolutely right. So yeah, but doesn't help anybody. So, okay, thank you very much. It was great. Thank you.